Problem 1 in foundation construction, and we use OSHA requirements, Occupational Safety and Health Act requirement for protecting excavation and workers when we do the excavation. And we sketched the excavation section for the following scenarios with different soil type A to G, soil type A, with different excavation depth, 18 for A, 11 for B, etc. To review the table that you had, table 10.1 for the OSHA soil and rock classification. So basically, there are four classification. The first one is stable rock. It defined as we see in the previous lesson video, and then type A, type B, and type C. And in table 10.2, we also have the OSHA maximum allowable slope for excavation site with different type of rock classified by OSHA based on table 10.1, so that you have it in table 10.2 here. And that I realized that in the sketch that you see there, and have to be less than the excavation depth, have to be less than 20 feet. So what it in here for the first scenario? So let's do one by one that you see there. Then A, soil type A, 18-foot excavation depth. So what does that mean? And with that soil type A excavation, so it should be the slope will be 3/4 one, as you can see there. So the excavation should cross section should be something like this excavation there, and then the depth 18 feet, and the slope it should be 3/4 horizontal and then one vertical. And from that one we can see the horizontal distance for this one. It will be 13.5 feet. And B, soil type A, 11 feet excavation, and of course that similar for B, and you can see the exactly the same for B. So let you see B is similar to A. So just the excavation depth is 11 feet. Now go to C. Soil type B, 18 feet excavation depth. So B, the slope it have to be 1:1. So we can have the excavation for scenario C 1:1. Then the excavation depth is 18 feet. And soil type B, so we have the slope is 1:1. So that here 1:1. And when it 1:1, then we have the horizontal distance for slope here is 18 feet. And that type B. D, soil type C, 30 feet excavation depth. So C, what should be the cross section look like? 30-foot excavation depth. And you can see here the slope, we only use slope for the excavation is 20 feet. If it's more than that, we may use other method, and that method it cannot be automatic. For the excavation depth 20 feet or more, we have to design the excavation by a professional engineer. So this one more than, so the depth is more than equal to 30 feet, so more than 20 feet. So what does that mean? We have to be designed by licensed professional engineer. So you cannot just follow the slope here. It only applies when the depth is less than 20 feet. As we showed you in the previous lesson video. E scenario. E. The first layer of soil type is C, 10 feet, and the second layer of soil type A is 5 feet. And we have a 15 feet excavation depth. So it should be the type A 5 feet and 10 feet. So with that one, the total depth is 15 feet excavation. So that means that it's less than 20 feet. So you can do with this slope. Other than that, if it's more than 20 feet, then we have to design by engineer, similar to C scenario. So in this case, what can I do for E? The first layer is type C, and the second layer is type A. So what we can do here, so let's draw down the layer. The layer here. Make the layer, as you can see there, 10 feet. And then the type C, that is type A in here. So that one, you can see, this is now this is type C, and with this is type A, and the depth of each layer that given is type C 10 feet and A is 15 feet, and the excavation depth is 15 feet total. So it go down to type A 5 feet. So what do we do? So for type C, it will be 1.5, 1, and type A 3/4 and 1. So what we do here, when we excavate, then we can excavate for type C. So we follow that one. Let's draw a little bit scale here. That, and slope is 1/2, 1, horizontal 1.5, and 1 for vertical. And then type A, horizontal 3/4 and vertical 1. So with that one, we have that become and 3/4 and 1. Not stop in here, not stop there. It's only 5 feet. So there, and that here 3/4 and 1. And that is the excavation. And similarly, it's symmetric. We can do on the other side similarly. You can see that. So the same slope on the other side. 3/4, 1, 1.5, 1. And the total depth maximum for the excavation here, 15 feet at given. So what does that mean? When more stable soil in the bottom, then the excavation slope, it will be follow strictly with the table 10.2. The next scenarios, when you have the more stable material soil on top and the less stable material in the bottom. So what should be the excavation depth? So the F, the first layer of soil is type A, as I mentioned, 5 feet, and the second layer type B, 20 feet, and the 15 feet excavation depth. So what it should be for this scenario. So let's do the same. So as you can see, type A 5 and type B 20. So let's do that. 5 and 20. And let me draw one side only. So it will appear 5 feet and 20 feet. And we have that is type B, and this is type, no, with the opposite. Type A top, more stable on top, and less stable soil in the bottom. And the excavation still 15 feet. So what it should be for these scenarios, So let's assume if I draw similar to E, which is that is D, similar to E, which is we follow type A, 3/4 1, and B, 1/1, right? 1/1. Then what it look like for our excavation? What it look like? So 3 for type A. So we go with the 3/4 1, and then we go with 1/1. You have that. Let's redraw it now. 3/4 horizontal, so it's something like more stable, more steep, and then it less steep there. So with that one, as you can see, so if it have this is 3/4 1 and this is 1/1, and you can see that it look not stable. The top, the first 5 feet is not stable because it's steeper than the bottom for sure. As you can see, it will be the soil, it will fall out. So it will be fall out. So what does that mean? When the less stable soil go in the bottom, then you just yield that slope and do that for both layers. So it will be continuous and it will be 1/1. So yield the less stable slope if the less stable material in the bottom and the more stable soil on the top. In this case, type A is more stable, type B is less stable. So that you will use the slope for type B and apply for the whole excavation. And in this case, only 15 feet. So we stop there. So slope is still 1/1, and of course we have that up here, and slope it will be 1/1 for both type. Keep that in mind. So not 3/4 and 1 if the less stable underneath. And that is the scenario F. And let's start for scenario G. We have the cohesive soil with the unconfined compressive strength of 0.63 ton per square foot or 60 kilopascal on the slope of 3 horizontal to 1 vertical. So that is the slope. So excavation not on the level surface, but it in slope. 10 feet excavation depth. So that on average, so 10 feet depth. Then we can use with these tables to determine the slope. If it's more than 20 feet, then have to call the licensed PE to design for this excavation. Keep that in mind, like scenario D we show there. So let's see what type of soil it is with the unconfined compressive strength of 0.63 ton per square feet, and with the slope is 3 horizontal, 1 vertical. So go to the soil here. If you go to type B, by definition, cohesive soil with the unconfined compressive strength greater than 0.5 but less than 1.5 ton per square feet. We a problem with 0.63, so it is type B. But it in excavation slope, we need to be more careful. You read the very bottom, the item number 6 in here. Material that's a part of the slope layer system, where the layers deep into the excavation on a slope less steep than 4 horizontal to 1 vertical, 4H, 1V, but only if the material would otherwise be classified as B. So yes, if B, but in the slope, excavation slope that less steep than 4 horizontal, 1 vertical. Our problem is steeper. 3 horizontal, 1 vertical. Then it cannot be in type B. In this case, we go to type C. It's more classified with this. Material, item number 5 for type C here. Material in a slope layer system with the layers deep into the excavation on a slope of 4 horizontal to 1 vertical or steeper. So that even if type B, but you have to apply the maximum slope allowed for type C based on the item number 5 in the type C classification there. Make sense? So with that here, this one, because in the slope, so the original right is here, and the slope for this original condition is 1 and 3, and you can see that, and steeper than 4-1. So when it's steeper than 4-1, then that one have to be like type B, but go down to type C. So the excavation, it look like if we start the excavation here, and we have to follow the slope of type C, which is 1.5, 1. So that here, 1.5, 1. And then we make the excavation. So that is the new cut that you have, and the slope have to be 1, 1/2, and 1. And one with that, and of course the average depth that we can specify, that is 10 feet. So keep that in mind with different excavation. Of course, when you have determined that, you can be able to find out the quantity, estimate the material to cut and fill, etc.